Welcome. I'd like to begin today's video with a little trick. It has a nice effect. What you need to do is grab a deck of cards, and out of that deck of cards, I want you to pick out 3 cards. So your 3 cards will be a 7. Any 7 will do. Doesn't matter on the suit. Hearts, diamonds, clubs, spades. It's all the same for this trick. Your second card is a jack. Again, the suit doesn't matter. And your final card is the king. Now, I'd like you to take these cards, shuffle them up, just these 3. You don't need any other cards for the trick. So you have 3 cards shuffled. Let's place them face down on the table so we can't see the 7, the jack, or the king. So those are unknown to us. Okay, now what you're going to do is take any 3-digit number you like. Let's just call the number A, B, C. Like it could be 1, 2, 3 for 123. But you don't have to pick that one. Pick whichever 3-digit number you like. Now, write that number side by side to make a 6-digit number. So ABC, ABC. Okay. The next thing that I'm going to get you to do is flip over any one of your cards and take the number that represents that card. If it's a 7, you take a 7. If it's a jack, that will represent an 11. And if it's a king, that will represent 13. So I want you to take that number and divide by whatever 3-digit number you just duplicated. So you're going to divide by this, first, let's say, question mark. Okay, and then we'll get some result out of that. And I'm going to just take a little guess and say that you didn't get a remainder when you did that. Okay, now that number that you just got, we're going to rinse and repeat. I want you to do this all over again. Take that number that you just got, flip over another card, divide by that card. And once again, you'll get another number out of the deal. Okay, so one last step. We're going to take the number that we just got, and what we're going to do with that number is we're going to divide by the original 3-digit number that you chose. Okay, now here's the effect. The cards were shuffled, randomly chosen. The number was randomly chosen. But wouldn't it be kind of cool if the remaining card was the result that we just got? And if everything worked out, it should be. So this is the 1001 trick. If you'd like a further description, it's in the notes with a little more detail written up. So I'm going to try to explain something kind of neat about these numbers 7, 11, and 13. It turns out that there's a quick way to tell if you have a multiple of these numbers. So let's read what it says. It says start with any natural number. So this could be a big number. Separate it into groups of 3. So where you often write commas, there's your groups of 3. And alternately add and subtract these groups. And we're going to start by adding the rightmost group, and then subtracting the second rightmost, and then adding the third rightmost, and so on and so on. So if the result is a multiple of 7, or 11, or 13, then the big number that you started with, the n, is also a multiple of 7, 11, or 13. Let's give this a try. So on the number below, we have 23,100. What we could do is separate it out into 23 and 100. So the 100 would make the first group of 3, And then the next group of 3 isn't a complete group of 3. It just has a 2 and a 3, but that's okay. Just start from the right and work your way to the left. If the next group is not a full group of 3, or the final group isn't a full group of 3, that's perfectly fine. And then we alternately add and subtract these groups, starting from the rightmost with an addition symbol. And if we do this calculation, we get 77. So 77 is a multiple of 7. And 11 is a multiple of 77. Now 13 is not a multiple of 77. So to answer our question, we can say yes, 23,100 is a multiple of 7, and yes, it's a multiple of 11, but no, it's not a multiple of 13. Let's try this with the number 1001. So if we take 1001, the first group is just like 0, 0, 1, or just the number 1 if you like. And then the next group is just a 1 again. So we'd alternately add and subtract these groups, and we end up with 0. Now let's remember that 0 is a multiple of every number. So 7, 11, and 13 are factors of 0, or 0 is a multiple of that number. So is 1001 a multiple of 7, 11, and 13? Yes, to all 3, because our test told us that the answer is yes. So you're getting a little bit of a hint of how the 1001 trick relates to the Jack, the King, and the number 7 in a deck of cards. So now we'll completely explain the 1001 trick, what's going on. Okay, so I had you pick any number that you like with 3 digits, and then you duplicated that right beside it to get a 6-digit number. What we could do is write this as ABC 000 plus ABC. So whatever digits you pick, I can just separate out that into this addition by just putting zeros in place. And now ABC with 3 zeros on the end is the same as ABC multiplied by 1,000. Okay, now we get to use the distributive law. So ABC can be factored out, and we're left with 1,000 plus 1 when we perform our distributive law. And 1,000 plus 1 gives us ABC multiplied by 1,001. And let's remember that 1,001 is a multiple of 7 and 11 and 13. And lo and behold, you get exactly 1,001 when you multiply those numbers together. And now let's think about what the trick made us do. So I had you pick this number, but secretly in my head, you're also picking this number. They're equal numbers. So instead of working with the ABC number, let's work with this number down here. So I'll just copy it again. You had ABC multiplied by 7, multiplied by 11, and multiplied by 13. And the first thing that I had you do is flip over one of the cards and divide by that amount. Let's just say you flipped over 13. I don't know which one you flipped over, but if you flipped over 13, then the 13s would cancel out on the top and bottom. And then I got you to flip over one more card. Let's say you flipped over the 7 next. So the 7 would cancel out on the top and bottom. And then finally, I had you divide by the original three-digit number, which was A, B, C. And that would cancel out on the top and the bottom. So the leftover card had to be that leftover number. And if we look back, we actually use some of the laws of algebra here. This canceling out on the top and bottom, that's employed by the inverse law. And also when we're saying we're going to divide by 13, for example, you can think of instead we're multiplying by 1 over 13. We're multiplying by the inverse instead of dividing by 13 as another viewpoint. It's nice to view it as multiplication because then you can see that none of the order here matters. The order of A, B, C, and 7, 11, and 13 can be jumbled up, and the order that you multiply 1/13 or 1 over 7 or 1 over A, B, C can also be jumbled up in any order you like. And when you multiply this amount by this amount here, you get that leftover card. In this case, the numbers that I picked produce 11. So that's an explanation of the 1001 trick. Okay, I have another trick to share with you. This one is called Phyto trick. So Phyto is a caricature from 7-Up. And I found this trick in an online app. That app is no longer active, so I kind of built it into our course with notes and a quiz. So you have to look at this video and then jump to eClass to kind of complete the trick. Okay, so it says, want to let me read your mind? Write down a number, make it completely random with lots of digits. So whatever you like. You could write down 3, 8, 5, 7, 6. Maybe I'll do that one just because it's the example here. But maybe you shouldn't do that one. You can write down whatever digits you like. It doesn't have to be 5 digits. You can use more or less. Then we're going to jumble up our digits. So I'll write 7, 5, 8, 6, and 3. So now we'll have two numbers. So what we're going to do is subtract the smaller number away from the larger number. Okay, so I've done my subtraction. Now I'm going to draw a circle around one of the digits in the answer that we just got. And we can't pick 0 because it's already a circle. So we're not going to reveal what you're circling on the other end of this video. So I'm just going to show you what the idea is. I circle the 8. And then we're going to jumble up the other digits. So I'm going to take everything but the 8, and it could be different numbers for you, of course, but my jumbled upness gives me. Okay, now I'm going to take this number, and I'm going to click on Phyto's quiz on eClass. I'm going to open it up, I'm going to click the quiz question, and I'm going to see if Phyto can guess my number that I circled. So go ahead and do that now and see if the effect works for you. All right, so the 1001 trick had something to do with the numbers 7, 11, and 13. Well, this trick has something to do with the number 9, and there's a trick for 3 that's similar to that. So we're going to explain all about how this trick works now. So a trick for multiples of 3 and 9. If you sum up the digits of some integer, let's say it's some big number, and that sum is a multiple of 3 or 9, then the big number is also a multiple of 3 or 9. So it works kind of similar to the other problem that we were doing before. This time, instead of it being groups of 3, we just take each individual digit. So in the number 333,111, we could test out 3 plus 3 plus 3, 1, 1, 1. right? These digits all get added together, right? It's the sum of the digits. So in this case, we would get 12. And if we test out for the number 12, 3 is a factor of 12, or 12 is a multiple of 3. And 9 is not a factor of 12. So is the number n a multiple of 3? Yes, but no for 9. Okay, let's try another example to get the idea for phyto trick. So I took this number, 780-937-8755, and I jumbled up all the digits right there, and I subtracted them like we did in phyto trick. So is the resulting number a multiple of 9? So I'm going to write down all of the digits, and then we're going to add them all up. So we get 45. And if we're thinking about a multiple of 9, isn't that kind of peculiar? 45 is indeed a multiple of 9. And is the resulting number a multiple of 9, of n equal to that mess of digits that we just got? Well, yes, because the 45 was a multiple of 9. All right, so what's going on here? If we take this original number that we started with, the 780 number, it has some remainder when we divide by 9. There's some leftover amount. It could be 0, but it also could be another remainder. We'll call it r. And if you're jumbling up all the digits, and it doesn't change whether you're a multiple of 9 or not, it doesn't change the leftover amount either. There's still the same remainder. There's still the same amount more than 9, or more than a multiple of 9. So when you subtract it, it turns out that that remainder is always 0. So that's why we got the 45. It could have been a different multiple of 9, but no matter what, it was a multiple of 9. Like it could have been 18 or 27 as well. So now I think we're all ready to explain phyto trick. Okay, so what we did is we picked a random selection of digits. Let's just say we picked A, B, C, D. And then we took those digits and we jumbled them up in a different order. So just say B, D, C, A, for example. And then we subtracted the bigger one by the smaller one. And we got some result out of that. Let's just call that result n. And what we know about the number n is the real key here. So n itself is a multiple of the number 9. So that means that when you take all the digits in n and you add them up, you get a multiple of 9. So let's just say n has the digits like a prime, b prime, c prime, and d prime. If we add up all of those digits, what we get out of that is a multiple of 9. Okay, so now what phyto does is when you circle one of these digits, let's say you circled b prime, then you jumbled up the a prime, the c prime, and the d prime, and it didn't change anything because addition is commutative. All phyto does is he takes whatever a prime and c prime and d prime are and takes that last amount and adds it up to some multiple of 9. Just adds whatever this sums up to plus adding up to some multiple of 9. And that's why phyto does not want you to circle 0, because then there would be a debate whether you had 0 or 9 circled. But because there's no circling 0, if you already have a multiple of 9, by adding up those green amounts, then you must have circled 9. Okay, so that explains Fido-Dido's trick. Thank you so much for listening, and we'll see you on the next one.